Good afternoon, guys. So this is going to be questions from 8.3. So this is homework. I'm doing the evens of part of the homework. So I'm looking at number 24, and the instruction says find the domain and range of each function. So this is the function that I have. It's a V shape. So I know that the function is going to be f of x is equal to the absolute value of x. There is a shift that you can see. Remember, the original one looked like this. I put it in dotted lines so you guys can see. And then we can see that this given point that we have here is moved 2 units to the right and 3 units up, which now it turns into this one. So I just wanted to kind of help you out to understand what the shift is. Shift horizontally, that's your H, that's going to go 2 to the right. And vertically shift, that's your K, that is going to go up 3 units. So keep in mind, with this section, there is a shift horizontally and there is a shift vertically as you go through this. So the question says find the domain and range. So the great thing about this, if you start looking at the type of questions that they give you, is that most of them will have these little arrows going upwards, which tells us that when we look at the domain, which will be the numbers that are representing in the x-axis, we get to see that if I begin somewhere out there in negative infinity and I start looking for where the x's are being used, we see that this arrow is going to continue to the left all the way through to somewhere out in negative infinity, but it's still going to be used as we go through it. The same thing with every single point that we have here. For example, 1, 2, 3, 4, 5, and then all of a sudden, dot, 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 we hit somewhere out in positive infinity. It's still being used. So we can say that the domain of the given function that we have is going to be the set of all real numbers, right? Remember, you can spell out all real numbers if you wanted to, or you can just put that R. Now, when you look at the range, we said that it was going to be represented by the lowest point that we have all the way up to the highest. And we said that we can create interval notation if we wanted to, or we can actually write it out. The actual answer to this is the set of all real numbers greater than or equal to positive 3. The lowest number that we have here, if you look at it, is 3 on the y-axis. So I know that that's the lowest point that I'm going to use. So I'm going to have to try to figure out how to express this in a way that y's are going to be demonstrated with this set notation that we have. So again, you can actually write it out and you can say the set of all real numbers greater than or equal to 3. So y has to be greater than or equal to positive 3. That's what it's asking you to do here. I mean, again, you can use the words if you wanted to, or you could just simply go ahead and do the set notation. Either of these two is fine for this particular problem. So here's the second problem that I would like to do. This is g of x is equal to the absolute value of x plus 2, which is basically telling me you have the original function. That's your V shape that passes through. It starts at the origin, and then it continues, and it goes on. We know the domain for this is going to be all real numbers. We know that the range for this is going to be 0 because it's located here. I'll put it in red so that you can see. And it goes all the way up, right? It's going to be used. All of these numbers are going to be used. So the domain for this really quick is going to be the set of all real numbers. And the range is going to be y is greater than or equal to 0, right? For the original function. For ours, though, what it's asking us to do is to be able to analyze and say, if this is the original, if this is the parent function, if I know that this is the basic one that I have, what does this 2 do to it, the function? Now remember, we talked about having a number inside either the parentheses or the absolute value. What that means is that we actually have an h, and this h has a horizontal shift. This horizontal shift is going to be the opposite of what we see. So in our case, we're going to take this point right here that now it's green, and we're going to move it 2 units to the left. And then all of these numbers that you see here they're in the dotted line. Now that they're green, if you look at it, all of these numbers are going to be shift 2 units to the left, that direction. So here's the original one. I'll put it in blue. And now, instead of putting dots, I'm actually going to draw it accordingly. So now I have an understanding of what it's going to look. To get the exact numbers that we have, remember you could always create a table, the X and Y table. And I know where that number is, that number that we have, the vertex if you want to call it. That will be -2, 0. I need 2 to the left of that. That'll be -3, -4. And then 2 to the right, -1 and 0. Fill in these points, and then you're going to be able to see how this the absolute value is going to look like once we shift it 2 units to the left. So now let me go ahead and look at problems number 50 and problem number 52. So I'm going to do these two for you so that you can see how they're done. We're going to take g of x. So here's g of x, and it's equal to x plus 2 square minus 1. So now I'm starting to notice certain things are popping out. The h is popping out and the k. H is going to be the opposite, which will be -2. My k, which is the vertical shift, is going to be -1. So let me draw the original one so that you can see what it looks like. So the original one is a parabola. I notice that it's positive, so it's going to look something like this. Actually, you know what? I should draw it in as a dotted line because that's the parent one, the original one. So now that I have it dotted, now you know that that's the original. It crosses through the origin. And now, how does this h and how does this k affect it? Well, I'm going to take this particular point that you see green, and I'm going to move it 2 units to the left, and then I'm going to move it 1 unit down. So here is this new translation that we see 2 units to the left. So this one is being moved 2 units to the left, and then 1 unit down. And now I can go ahead and create my U shape going upwards, and that's what the g of x is going to look like. Let me continue doing number 52. 52 g of x is equal to the absolute value of x plus 4 and then plus 3. So again, things that are popping out for me, h, my k, and I see that h is the opposite of what I see, so it's -4. That means I'm going to move to the left 4 units. My k is going to be +3, which means that I'm going to move up 3 units. But how does the original one look like? The original one to this given function is the V-shape one that we did. And remember, the original one is always going to be dotted. The translation is the shifts that we have. So I have -1, -2, -3, -4. And then I'm going to go up 1, up 2, and then up 3. So the way that this looks like is going to move this vertex or the crucial point that we have, and then I'm going to move it 4 units to the left. And then I'm going to move it 3 units up. So now my new vertex is located up here, or the crucial point I should say, and now I can actually draw it. It's going to be going upwards like a V. And remember, you could always double check if you want to be specific as to what values you can use for the table to make this V shape look pretty. You know that the first point that we looked at was -4, 3, and then you use 2 to the left, so you can use -5, -6. Then you can use -3, -2, and just fill in by substituting it in, and then be able to obtain these points and move on to see how the original function is going to look like. Like always, I always encourage you, please make sure you try to do the homework before you come to class. That way you have some really good questions and continue working. Okay? Thank you.